and I'm very happy to be here. Thanks to EC Council for inviting me to be a part of this Cyber Talks initiative. And today, the topic that I'm going to be talking about is an introduction to security automation. This is a topic that's very close to my heart, and I've been working on this topic for a while now, actually. And in fact, I've been doing a lot of research on security automation. A lot of open source products I've released on security automation. So this is a topic that's very close to my heart. And I'd like to talk about this and talk about some of the challenges and some of the needs for security automation, so to speak. So this is a quick introduction. My name is Abhay. I work for a company called V45. V45 is an application security focused company. We do a lot of work around consulting, training, testing in terms of application security. We also are heavily invested and entrenched in security automation because we do a lot of automation work for our clients. We also do some work around DevOps and security, which is a very, very important aspect. I'm going to talk about DevOps and security today, and that's something that we do. We do a lot of trainings as well as part of our initiative in educating the community at large. So this is my introduction. I've written 2 books, one on Java and one on PCI compliance. So let's get started. Today's session, I'm going to be talking about 3 things. One is, I'm sure people who are listening in on this webinar will know that security testing itself has undergone a huge change or is undergoing a huge change. There are a lot of disruptors coming into security testing that is causing a massive shift in the way things are done. So for instance, some of it could be DevOps itself is a big area of engagement for security testing, because previously security testing used to be done one way, and now with DevOps and continuous delivery, it's being done a completely different way. So let's look at what is the shift in security testing. Next, let's talk about some of the approaches to continuous security testing, because one of the things that a lot of organizations, a lot of our clients have figured out is that they need to be identifying vulnerabilities or identifying security issues continuously because their apps are being delivered continuously. So we look at some aspects of that, and then we'll have some conclusions and summary based on what we've discussed today. Right? Now, if you look at the modern application delivery landscape, you'll see a massive shift in the way things are done. Right? Earlier, we used to have companies delivering apps very infrequently. So it would be maybe once a month, or if it's a much larger or stodgier company, you would have it once in 6 months, once in a year. Application delivery or development efforts used to be large, long drawn systemic items that used to be huge or largely built out. Today, that whole concept is changing, and a lot of that change has been brought on by the Agile and DevOps movement. Agile, of course, earlier than DevOps, but both of these things have really transformed the landscape of application delivery. So what is happening is that applications or application development companies want to reach their customers faster, or want to deliver apps to their customers or their users faster, much more efficiently, much more effectively, with lesser bugs, with lesser issues. So they're doing things faster. So what is happening is companies like Amazon or Etsy, or even if it's not for these massive internet companies, we're even talking about companies that are building in-house apps, want to do things quicker to reach their users faster. So these companies are going at a faster pace. For instance, if you see this, Amazon is deploying apps to production every 11.6 seconds. That is according to their own admission. Etsy, you can look at a presentation from Etsy, which is an online retailer for handicrafts and handcrafted products. They deploy their apps 25 times a day, which means that every day their apps change 25 times because of some small change, something new in terms of UI, or a new feature added to the mobile app or something else. They are changing their app, or they're deploying their app 25 times a day. This is causing a huge speed bump in the way applications are delivered to the customers or to the users of these applications. Right? So what is happening is that DevOps has become the way that they're doing all of this, right? DevOps has been the underlying movement that has made all of this possible. Now, DevOps is essentially not only technology. A lot of people think of DevOps as automation, and more automation, which is not really true. DevOps is more a movement. And what DevOps does is that you have 2 disparate or previously disparate entities, which is developers and operators, and these folks used to be constantly at loggerheads with each other simply because the developers would create a piece of code, then the deployment package would be given to the ops folks. The ops folks would deploy this package and then realize that a dependency was missing, or some other issue comes up, or some other functional issue comes up which requires it to be brought down or rolled back to the previous version or whatever it is. So that's the reason there was a huge deal of friction between dev and ops, which created DevOps. And DevOps is not actually very new. It's been around. Anyone who's deployed apps in terms of an automatic deploy, or who's implementing stuff like continuous integration, continuous delivery, or some combination of any of these is already doing DevOps. So DevOps essentially is just a movement that has reduced or aims to reduce the friction between dev, the developers, and ops, the people who actually deploy and manage the service once it's deployed. So what is happening today is all of these previous steps, requirements, design, develop, test, deploy, are becoming integrated as part of the DevOps pipeline. A lot of this is automated today. A lot of this is more streamlined with a lot more collaboration going back and forth between dev and ops teams. So this is great, right? Now things like this are happening. So if you look at this is an example pipeline where the developer codes and commits something to the repository, and then an automated set of events is triggered, which builds the application, runs the functional testing suite, runs the performance testing suite, runs all of this different stuff, and deploys to production or deploys to the staging environment automatically. All of this is done in a completely automated way. And if you leverage technologies like containers, like Docker or any other containerization technology, you will see that this has become much more streamlined. So you're able to deliver applications much faster, package applications much faster, and go much faster in terms of your own application delivery process. So these pipelines have kind of become reality. So what is happening, however, is security is still kind of getting missed out, right? Now this is always a problem, and security still is a gatekeeper sort of a process. A lot of security initiatives are done towards the end of this. So just before you deploy, security is kind of done somewhere here, where the testers are brought in or the security teams are brought in, and they have to test and validate whether they're ready to go to production or whether they're ready to go live. And this actually causes a whole bunch of problems, right? So let's talk about some of the issues. Now, if you look at the cost of fixing security bugs, or any bugs for that matter, this is an IBM report which talks about the cost of fixing bugs. You look at, if you fix bugs early in the life cycle, they tend to be cheaper. So for instance, if you are able to fix bugs as you are designing them, so let's say you design something that is fault tolerant or automatically takes care of security issues or other bugs in the design phase, then you're actually saving a ton of money. But when it goes to implementation, when the developer codes it and when the developer actually writes code and gets it ready for a build, that time the cost of fixing that bug is 6 times or 6x, right? That is 6 times more expensive than it was in the design stage. And when that bug goes to the testing stage, when the developer actually finishes the build and the tester starts testing it, the QA or the security tester or the performance tester start testing this application for these bugs, then the cost balloons to 15 times the cost. So you see that fixing bugs earlier is makes a whole lot more business sense, right? Fixing it earlier, because it's rising as we go forward. But once it goes to production, that's when you see the massive leap that you see. You look at from 15x, it goes to 100x, simply because once it goes to production, that bug is now much more expensive, because it could be a security flaw. So let's say it goes to production, somebody compromises your application with a SQL injection attack and steals a bunch of credit card numbers. Obviously, that cost is huge. That cost is massive. That cost becomes very, very prohibitive. It also attracts penalties. It attracts legal fees. It has all of these things. So the cost of such bug or such bugs in production is way more. So obviously, our motivation should be, let's find bugs as early as possible in the life cycle. And to be honest, security flaws are nothing but bugs. They're just bugs, just like functional bugs or performance bugs or any other type of bug. They are bugs. So treat them as bugs is one of the things that we're going to be talking about through the rest of this discussion. Unfortunately, with security, this is the line that we have seen that causes problems for all of us, right? Let's do a security test just before we go live. A lot of us have seen this. I'm sure a lot of you would have felt the pain with the statement I'm saying right now, where you see that the security test is done as a last priority thing. A lot of folks don't even care about the security. They just see it as a checklist item they want to finish before they go ahead. And this is really ruining it for a lot of us, simply because once you do it, you are really coming back to this trade-off, right? You are coming back to the point where it either costs you 15x or it costs you 100x, because you have only two choices. Let's say you are about to go to production and you do a security test and you find a whole rash of security issues. You're left with two choices: either delay the build, which is causing this cost, or you deploy it and you potentially incur this cost, which is again sometimes not even affordable, not even feasible for organizations to incur. So this is becoming a very huge problem. I'm sure you guys will agree with me when I say this. So in short, what we're seeing is that application delivery is going really, really fast, and application security is trying really, really, really hard to catch up. But the application security process, I'm sure as you could see, is failing to catch up. And that is why we need something more scalable. We need something that is a little more DevOps oriented. We need to also invoke certain types of automation. We need to solve these problems a little differently than we used to before. So what is the need of the hour? One, we need to find and fix security bugs early and often. We need security to integrate with your development processes. So we need it to integrate with the software development lifecycle itself, with your agile development process. And if you are an organization that is delivering applications continuously, you need security to also be included in that continuous delivery of applications. So it's part of, that's called in the application delivery terms, it's called a continuous delivery pipeline. And this needs to be followed from a security perspective as well. So if you look at security in DevOps, this is what I'm talking about, right? This is a slightly high-level perspective of security in DevOps. On top, you would see the Devops pipeline, which is not very different from a lot of application delivery pipelines, only that all of this is done incrementally and in sprints or in shorter bursts, right? Feature by feature, functionality by functionality, and so on. So you essentially have the plan, code, build, test, release, deploy, operate, and monitor. Now, these are typically DevOps pipelines or continuous delivery pipelines that organizations set up. So as soon as the planning is done, the developer writes the code, or the planning happens along with some of the code, depends on the iteration, and then the build would be triggered sometimes automatically. Most of the times this is happening automatically today. A lot of the functional tests are run automatically. Releases automatically go into a Docker container or to some kind of a repository, and then it's deployed to multiple environments through an automated process. And then monitoring also happens through some of the automated triggers that you've set up. Now, security also has its place, and as you can see, we are not doing security at the end somewhere here. We are actually doing security all across the life cycle, and that's very important. All of you need to understand that security needs to be done not just at the end here, which is how it's done currently. It needs to be done all across the cycle. So we need to start off with, when we are planning, we need to do a threat model to figure out, hey, what are the potential threats that can hit our application? Then once we start coding and start to build, we need to run static code analysis, which is called SAST, static application security testing. And we need to run composition scans. One of the other things that we need to desperately do today is identify security issues with third-party libraries or components that we're using in our app. So if we can do that, we're able to cut out a lot of security flaws as well, right? A lot of the major corporations in the world were hacked only because their libraries were not updated, their Java libraries were not updated, or their PHP libraries were not updated or patched, or they're not upgraded to the newer version or the more secure equivalent of that particular library. So both these things are important when the developers start their coding process. Now, once the developer finishes his or her build, that's when, gets ready to test, that's when you trigger your dynamic application security testing or interactive application security testing, where you would have the scanners or vulnerability assessment tools running against the application, or you would have an instrumented vulnerability scanner running against your application to identify any security issues that the developers have introduced or the deployment has introduced. And once you're ready to release, you need to scan the environment or test or security test the environment that is being deployed in. So let's say you're deploying it in AWS, you need to probably do some security checks on it. Let's say you're deploying it in your own data center, obviously there would be a lot of security checks you need to do at a deployment level there as well. And once you deploy the app to production, that's when you need to start monitoring it. And so all of this essentially facilitates a continuous process. So as you can see, you're not doing it at one point, you're actually doing all of this at different stages. So you're actually filtering out. If you do a good job of this, chances are that you'll find fewer flaws in this stage, fewer flaws in this stage, and then fewer. So you are essentially creating a force multiplier effect to ensure that you find the lowest possible number of vulnerabilities as you go to production, which means that you are much safer and much more secure when you deploy your applications. So let's start with this first. I'm going to talk about threat modeling the last, because I feel that there is a certain value to talk about it after we discuss this. So let's talk about certain automation efforts that we can take up in the SAST and SCA phase. So SAST is static application security testing. SCA is source composition analysis. And source composition analysis, as I mentioned before, is the practice of identifying security flaws with your dependencies, third-party libraries and dependencies that you're using in your application. So let's talk about these. And one of the things that we've been working on, and my team and I have been working on, is automating this process. So one of the things that we do for a lot of our clients is, hey, you know what, the developer writes code. As soon as the developer writes code and it goes into the Git repository, we trigger an automated process of scanning that, the change in the code or the entire code base to find security issues, right? Now, a lot of this can be done with open source tools. Tools that you don't have to pay literally even a single dollar for, right? A lot of this can be triggered. So let's say you're running PHP or Ruby or Python. You have so many tools that can identify security issues with these frameworks and these platforms, right? And these are free. For instance, Java has find-sec bugs. Node.js has Node.js Scanner. Ruby has something called Brakeman, which is a great product, which are all open source. And you can use this in your process. So let's look at some of the automation approaches to SAST and source composition analysis. And we'll talk about some of these things that you can do in terms of automation. So one of the things you can do with SAST is push it into a continuous integration pipeline. So this icon is that of Jenkins. Jenkins is a very, very popular continuous integration service that runs every time, or has a bunch of jobs that are triggered every time code is checked in, or it can do a bunch of tasks. So Jenkins can be used as a task runner. It can be used as a continuous delivery pipeline. A lot of, you could use Jenkins for a lot of different types of software delivery tasks that you have. So as soon as the developer checks the code into the Git repository, Jenkins would trigger our scanner. It could be Brakeman, it could be Bandit, it could be so many different scanners. In fact, if you look at our V45's GitHub repos, you'll find a lot of open source tools for a lot of these scanners as well. So you can just use this in your pipeline very quickly and get started quite easily in your own automation efforts as well. So Jenkins would be triggered. If Jenkins finds, or if the tool finds security issues, then that would be written back to the Git report to say that, hey, these are the issues we found, please fix it before you commit that code to the Git repository again. So the developer goes in. So this is a very fast process. As you can see, the developer gets immediate, almost nearly immediate feedback on the code that they've written, on the libraries that they have. In fact, if you're using GitHub or one of these repository management tools today, you would see that they automatically find security issues in your dependencies. In fact, GitHub recently announced, and I've seen this in my own code as well, where they are displaying or they are sending you notices saying, hey, you're using Python crypto library version 2.1.6. And 2.1.6 is vulnerable to this, so please upgrade to 2.1.6.1. So they're actually giving you proactive alerts. So a lot of tools actually do this for you. And even if you are not in a situation where you can leverage some of these tools, you have other tools that you can leverage as a part of this process. So this is great, and this is something that a lot of our clients do when they're doing source composition and static code analysis in the continuous integration process. The other thing that a lot of implementations we're seeing is running the entire process as a separate process. So this is something that I am a big fan of. I use a lot of container technology when I'm automating stuff, because containers allow you to isolate some aspects of the code so that you can run it as a separate container, and that does not require dependencies to be managed. A lot of this is pre-done and given to you. So once the developer checks this into the Git repository, a Docker image or the Docker container respond with the source and source composition tool or the source code analysis tool, and it will run and identify a lot of the security issues and write it back to the developers process and say, these are the issues I've identified, please fix this, else otherwise I won't allow you to check in. So these are some of the things that you can do as well, depending upon what kind of process you'd like. The other thing that we're also seeing is immediate feedback to the developer, right? So in this, the developer has an IDE or uses a particular development environment where there are already security coding rules built in. And as the developer writes the code, the process checks for the security issues and flags of, hey, line number 43, I see a SQL injection, please fix it. Line number 67, I see a command injection possibility. Line number 84, I see cross-site scripting. So the tool automatically gives you an immediate analysis of what is happening with your code, or you could even do that with Git Commit Hook. So one of the big automation, success factors, or one of the ways you can do a lot of automation with your developers is to use something called Git Commit Hook. So where you can set up a hook that says, as soon as somebody commits to this Git repository, run this process, run a static code analysis tool, or run a different, or a code quality tool, or whatever it is that you have as part of your security processes. This will actually reduce a lot of the effort that the security team has to eventually do later on. So security teams today are small. I'm sure you've seen this. I'm sure many of you are working in security teams where you are part of a 1 to maximum 10-member team. And 10-member teams are for a very large organization. So if you are in this situation, you want to be able to make engineering teams as self-sufficient as possible. And you can only do that with targeted automation, right? So a lot of this you can achieve with that targeted automation. So we will move on and we'll talk about dynamic application security testing. And this is the next step of your security testing pipeline and automation as well. Now, this is where I've done a lot of work and a lot of research, apart from the SAST part of it as well, because this is the tough part. This is actually a pretty complex process, and this also tends to get a little complicated as you're getting into this. This is a little more involved and a little more complex. So one of the things that we are seeing is we need to leverage software test automation. I'll talk about why we need to do that in a little bit, but this is something that we definitely need to be doing in our process. We'll also talk about something that I would like to call custom exploits or security regressions. We'll look at this, and we'll talk about correlation and aggregation. One of the big challenges that we are seeing today, especially with web apps or web services or mobile apps or whatever, is that the previous way. Now, if any of you have tested web apps before or web services before, you would see that the old way of doing things would be spidering stuff, right? So you essentially open up a Burp or a Zap or whatever tool you have, and you access your application through the proxy, and then you start spidering the application. Burp and Zap start to discover more URLs, and then you use those URLs to try and perform your attacks and then identify the security flaws. Now, this is becoming quite a useless practice today. And I'll tell you why. Simply because today you're up against web services or highly interactive single page applications or high JavaScript engagement type pages where the spider does not really find anything. So if it's a web service, let's say you're testing a REST API, you don't really have a spider, right? Because the REST API does not have links in a web page that it will be able to refer you to. Or if you're testing a single page application, all of the links are generated as the user puts in the right input. So let us say you're testing a single page app of a airline booking site. Only when you put in the to and from and the dates, you will be actually able to get links for these flight options and all of that stuff, which a typical vulnerability scanning spider will not even find, will not even be able to look at. So this has become quite useless. The spidering process has become largely useless. I would say it has become not very effective against most of these apps today. However, you have a huge advantage in one way that you're not even looking at, which is your QA teams. Now, QA teams create something we call software test automation. They use Selenium or they use Tavern or whatever it is. They use different types of frameworks to write software test automation to look at or find functional bugs or to test against functionality errors. Now, that is a great resource to use. So, what I would do is pass this software test automation through the dash scanning tool. So, I would pass it through a burp or a zap or an acne or a W3F or whatever it is. And then once it passes through this proxy, I would scan for the security issues after it's done running. So, it's almost like a user is actually interacting with the website, except that the user is not. It's a script that's interacting with the website or the web app, and then you're scanning it based on that. That actually is much more effective because you can do a better job of authenticated scanning. You are also able to perform a much more powerful analysis of the tool because you're able to get the right inputs and the right outputs, and you're able to figure out the security parameters for it. And the other thing that you're also doing is restricting the scope. One of the big challenges with spidering a target is that the spider goes crazy, right? It finds outer scope URLs, it finds URLs that are huge, it might find PDFs or PNGs and CSS files that you don't even need to test because it's spidering stuff, right? So if you use this kind of parameterization, you're able to restrict the scope to modules that you want to actually test and focus on, and then integrate this. And this you can integrate as a completely automated process. That's one of the big benefits of software test automation. So what we do typically is run Selenium. So Selenium is a very popular browser-based testing framework where you can run it through a particular proxy, or you can run it through Jenkins, or Jenkins can control this. You can run it through all of the tools you have against the target, and the tools would start to kick in and perform the scan subsequently. So this is a process that we have. In fact, in this process, we're using our own tool to do the vulnerability correlation as well, where you can run Selenium or any other kind of a testing framework like Robot or Swagger or whatever it is against, by proxying it through one of these scanners, right? So I would proxy it through Zap or Burp or Arachne as an automated process, and it'll test the application. And all of this, as it is processing through these proxy tools, you can actually find they would be able to capture the back and forth traffic, and once the test tools are done running, they can actually perform their security testing against the application. Now this, as you can see, is a completely automated process. And if you have a QA team, chances are that they're already building out all of this stuff for you. So you can just leverage. In fact, in one case, we had a company where they had a QA team that they were building in Selenium, and within 2 hours, we were able to completely set up an automated security testing pipeline because we just routed all the Selenium scripts through one of these scanners or two of these scanners and run a completely automated security testing process, which was amazing. So this can be invoked from Jenkins or any other continuous integration service as well, as I'm sure you will know, because you can invoke this as a simple command line script or as a more complex tracking system. A lot of these scanners have API. For instance, Zap has a great, OWASP Zap is a free tool, has a completely customizable API. You can use the API and you can proxy all of this stuff. You can control the entire tool through the API. Burp Suite is a paid product, but it's not very expensive. It's great, and you can use the API of Burp Suite to do a lot of stuff as well. Arachne is a free tool. It's an open source tool, but if you want to use it commercially, you have to, I think there is a license involved, and you can use the API of Arachne. All of these tools come with API, and most of these tools are either very inexpensive or free to use. So you can use some of these tools, or if you already have a set of tools that you use, look at the API and see how you can stitch it up. If you want some help, let us know, and we can always help you out with some of this stuff as well. So the other thing that you would also assume that, yes, okay, this is all great. We do security testing and so on. We use Zap, we use Burp, and it finds SQL injections, and it finds cross-site scripting, and it finds some of the other security issues. But what about the more complex, unautomatable or non-automatable type of testing? Right, let's look at authorization flaw. Let's say I am able to escalate privileges from one user to another user through tampering with a particular parameter. And that's a very manual test, right? You can't really automate for that. So one of the things that we do in V45 is something called security regressions. And security regressions is a very powerful way of actually managing the entire flow. So let's say you have a pen test. Let's say we are running a pen test, right? So we run a pen test and we find this kind of an authorization flaw or some complex crypto flaw, something that the scanner does not find. So what we do is we sit with a QA tester, or the pen tester herself automates this and creates an automation script for this particular flaw. And once they create an automation for this flaw, you can test it n number of times to check whether that flaw still exists or not. And this is way better than providing PDF reports, because one of the big challenges that developers have is, hey, how do I recreate this flaw? And this script essentially helps you recreate this flaw. And this is like you have functional regressions and so on. This is called a security regression. So let us say you have external pen tests, bug bounties, whatever. You can create that as automated scripts rather than storing them as PDFs which nobody will read. Use that as an automated script and run it back in your continuous delivery pipeline, which becomes a much more repeatable and scalable process. So that again is, now apart from your dashed scanners, you can also have your regression scripts that you include as part of your entire process to run dashed. So really, if you look at it, our framework has a combination of everything, right? You look at security testing, our automation really takes everything into account. We have SAST, where the developer, once they check in code, we have the security automation running to identify the code based on security issues. We have this source composition analysis or the dependency security validation. We run our tools with a DAST or vulnerability assessment, automated vulnerability assessment, and then we also have our own regression framework that you can use. So this is really a complete package when you look at automation. And of course, you can find a lot of this available on our GitHub repo or on our blog. So just go to our V45 blog and you should be able to find a lot of resources on how you should be able to do some of these automation focus areas. So one of the example pipelines that I set up recently was using GitHub to find security issues. Once the developer writes code, it checks for static code analysis. In this case, we use check marks, but we also have other tools that we can use like Bandit or Breakman, which are open source. And then in this case, it was Node.js app, and we used npm audit to find the dependency. So npm audit is a free tool from the Node package manager company, where you can use it to find dependency security issues in Node packages. And once all these are found, we go and run the parameterized test with Zap or Burp or Arachne, or these processes. So this becomes a completely repeatable and scalable process. And as you can see, just like you create a Devops pipeline, you are creating a security pipeline, which is great. You also have OWASP dependency check, which is a great tool to identify dependencies in your dependency security issues in your code or in your libraries. That is free as well. You can use that to leverage some of this stuff. The other thing that you should also be doing is working with other engineering tools. Now, stuff like Jira. Now, most developers would use Jira or some other bug tracking tool. I say push in security flaws as bugs into these bug tracking tools, because what happens is that developers understand and read these bug tracking tools, because for them, they work in terms of, oh, I need to fix these many tickets today. And if this becomes part of that ticket management process, it's much easier to for them to actually fix the bugs, and they get more priority for the bugs. There's more visibility for the security issues. So, and Jira has a lot of tools that help you automate. Jira has a great API. It also has webhooks to be able to track the status of that particular bug or that particular issue that you've raised in Jira. So the last thing that I'm going to be talking about today is threat modeling. Right now, threat modeling is one of those things that, yes, automation does exist, but unfortunately, a lot of it still is manual. So let me talk about the reason why you should be doing threat modeling if you're not already, and how you should be doing threat modeling, maybe to increase some of the effectiveness of said threat modeling processes. So one of the big problems with threat modeling today, and why it's very important, is this, right? One, when you do threat modeling, you are able to actually envision security threats. So let's say you're threat modeling an e-commerce system. One of the threats you would come up with is, hey, somebody could try and steal my credit card data, or somebody could access my user account and perform transactions as the user, or somebody could steal discount codes and rob the company of several millions of dollars in revenue. Now, these threat models help you define what kind of threats are going to be used against your application, who are the kind of people who will be attacking your application, or what are the actors that will be attacking your application. And it will also help you break down the most relevant threats to any system that you have, right? So that's great for the threat model, right? Unfortunately, today threat models are large documents, and they're not done in a very quick way. They're not done as part of the development lifecycle. They're done once a year, once in 3 years, and they generally, when threat modeling is done, they produce massive tools or massive documents, which 150 pages and so on, which nobody will ever read, right? So threat modeling is something that you need to make a much more iterative and repeatable and scalable process, just like you make every other thing in your automation pipeline. So I'm not going to get into the benefits of threat modeling. I think that's quite well known. But what you should do is integrate threat modeling into your agile process, which means that every agile process, if you are familiar with agile, you would know a term called user story. Now, a user story is nothing but a description of functionality of a particular thing. So let's say, as a user, I would like to access my account so that I can perform, shopping transactions with it. Or as a user, I would like to access the shopping cart to be able to shop for certain products that I bought on the e-commerce site. Right? So that would be a user story or a functionality description. What you should do when you're threat modeling is create an abuser story that says, hey, as an attacker, I would like to steal the user's access to the user's account so I can perform transactions as that user. And then once you create the abuser story, you actually break that abuser story down into scenarios and say, okay, how do I achieve this abuser story? So in this case, I would say maybe do a SQL injection attack, or try and do a man in the middle attack against the user, or do a CSRF style attack against the user, or do some other kind of command injection attack against the application so that you gain access to the user's account, so on and so forth. So what you are really doing is including a threat model in every feature that you are planning to build. So every feature that you are planning to build automatically has security threat models built in, which gives you a set of mitigation steps and helps you get to your security goals much faster. So it helps you identify security at the earliest possible stage in your development lifecycle. Right? That's the great thing about iterative threat modeling. Now, while there is not much automation around threat modeling, we have created our own open source tool that is free for all of you to use. It's called Threat Playbook. It's available on our GitHub repos. You can look for it, download it, see how you can use it. It's also being featured at this year's Black Hat and DEF CON. I'm going to be doing presentations in both of these places around this, as well as a lot of other automation subjects. While I'm not going to be getting into Threat Playbook because time is short, I would really like for you to let us know how you think of it, what you think of it, and how you like it, and how we can improve as well. So Threat Playbook essentially allows you to capture all of this as code. So you can capture this in a completely automated way, and you can even run automations from Threat Playbook and it link back to the threat models. And it becomes much easier for you to be able to manage threat modeling rather than create massive Word documents that are then converted into PDF. In this case, you can keep this as code, you can use this, you can check it into GitHub, you can add iterative functionality to it. It becomes much easier to manage. So with that, I'd like to call it a day. Thank you very much. I really hope you enjoyed this session, and I hope it was useful. I once again would like to thank EC Council for inviting me to give this cyber talk, and I'll be happy to take any questions now, if you can. Thanks.